Okay, in this regard, in the concept of probability, first we'll check this concept of head and tail when we have a coin. So, as all of you know, that every coin has got two faces. The first one is head, and the second is tail. So, these are old notes I have got. So, I have mentioned here Omani coin. So here we have head and this one is tail in our coin where the picture is there, some sort of that crescent or moon is there, that is called head and the other side is tail. Um, so in head and tail, suppose a fair coin is tossed once, what is the probability of getting a head and a tail? So once we toss one simple coin, so then we got what's only head and tail. But mathematically, how can I show that? Okay, mathematically I can show that. See, this is the common formula: faces raised to the power. And now a coin has got two faces, and I'm tossing it one time. So this is only two outcomes. Now this is the sample space. Head will come and tail will come. So normally I can just write head and tail. So what is probability of head? So the probability formula is m by n, favorable divided by total. Now here how many heads we have? Only one head out of total divided by 2. Similarly, what is probability of tail? Here we have how many tails here? One, and total out of 2. So this is for one coin. Now if we have the same coin, we, we toss it twice, or we have two coins, we toss it once. So find these probabilities. So see, this is an easy way. This is what we called a tree diagram. This is head and tail, and again with each one I'm writing head and tail. So see, head head, head tail, tail head, and tail tail. This will be the sample space. Check solution. Faces raised to the power n is the same formula. Now a coin has got two faces and I'm tossing it two times, or two coins one time, so it's the same. So this is 2 cross 2, which is 4. So head head, head tail, tail head, and tail tail. See, head, you can get it from this one. Okay, so this is head, head head, head with head, head with tail, and similarly tail with head and tail with tail. So that's how you can get the sum. Now the probabilities I'm interested in is that, see, probability of exactly one head. So probability of one head means that how many of these four have one head. So we can see that, see, here we have one head and here we have one head. So there are two. So this is two out of four. Two tail. So you can see that there is only one option where we got two tail. And then we have at least one head. Now this is interesting. First you need to understand at least. At least means that come as come. At least means that you have to start from him. One and more than one is acceptable. So at least one means one head and more than one head is acceptable. So see, two by 3 by 4, and at most means maximum. Maximum one and less than one is acceptable. So this is one and one tail, and this is zero tail. See, so that is also acceptable. Similarly, this is for three coins. Three coins. That's how you can find. See, that's how you can find head, 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 tail, head, tail, head, tail, tail. Then the tail, head, tail, tail. Then tail, tail, head, tail, tail. So that's how you can find the sample space. Formula is same, 2 raised to the power 3. So 2 means 2 cross 2 cross 2. That's how you can get the sample space. Now the required probabilities, you can just check how many 3 heads are there. Check. This is, first one is one head. How many have one head? So here 1, 1, 2 and 3. It got 3, so this is 3 by 8. 2 tails, so same have got 2 tails. See, at least one head means that one and more than one is acceptable. So this 1 is acceptable, 2 are acceptable, and 3 is also acceptable. So this should be 7 by 8. At most one tail. One tail means one and less than at most. So one tail, and one tail. 1, 1, 1, and 0 tail is also acceptable. So this is how we can find for 3. And fair coin is tossed 4 times. I have given this. Okay, you have to complete this question. Find the given probabilities. Now, apart from that, we have dice. This is a dice. इसको आप चक्का कहते हैं. सही है, लूडो में जो कहते हैं. So if you toss it 1 time, so the formula is same. Faces raised to the power n. 6 raised to the power n, because a dice has got 6 faces. So 6 faces. 1, 2, 3, 4, 5, 6. So what is the probability of getting 4? There is only 1 4, so 1 by 6. Even dot 3 by 6, 2, 4, 6. Odd dot 1, 3, 5. That is again 3 by 6. Divisible by 3, so 3 and 6 is divisible by 3. Multiple of 4, that is 3 by multiple of 4. That is not 3 by 4. Multiple of 4 is only 1. So there is only 1 by 6. Prime dot, so we have got 2, 3. These are prime numbers. Prime numbers are those numbers which is divisible by itself only. Okay, so here we have 2, 3, and 5. All 3 are what? Prime numbers. So what will happen if we toss 2 coins? Maximum 2 dice it will come. So see, again the formula is faces raised to the power n, 6 raised to the power n, 6 raised to the power 2, 6 plus 6, 36. So that will be the sample space. 1 with 1, 1 with 2, 1 with 3. Similarly 6 with 6. This is the sample space. This is in red. Okay, and here probability both dots are same. So you can see both dots are same. So here look, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So both dots are same. Next, they are asking both dots are different. So apart from these 6, all are different. First dot is a multiple of 3. So see here we have first dot, that is multiple of 3. Similarly here we have first dot, that is a multiple of 3. We are interested in that. Second dot is a multiple of 4. So we will check second dot. This is second. These are second dots. These are second dots. Okay. This 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4. Only this one is multiple or divisible by 4. Now sum of dot means that if we add these two, look, 1 plus 1, 2, 1 plus 2, 3. So that I have written over here. This is called sum of dots. So 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, and till 12 we have. The sum of dot is even. So you can check how many even numbers we have. 18. Sum of dot is prime. How many prime numbers we have? 2, 3, 5, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So we have 14 prime dots. So on you can find these probabilities. Now product of dot means that we have to multiply both the dots. So that you can find these probabilities. Finally we have these cards. In cards, look, this shape is known as club, this is known as spade, this is known as heart, and the last one is diamond. I have mentioned this. So in this we have total 52 cards. Black are 22, 26, red are 26. These A cards are aces. These J means jack, Q means queen, K means king. And these face cards, these are called face cards where we have picture. So probability of black card is 26 by 52, red card 26 by 2, spade, we have spade cards. Look, these are spades, all these. So these black spades. So spades cards are 13, heart cards are 13, diamond 13, king or queen, jack. So these probabilities you can check. Okay. Finally, this is the axiomatic definition. This means that probability can never ever be a negative value. It will always in between 0 and 1. Probability of sample space is 1. And if we have mutually exclusive, so we can convert this union into plus. This is just the final thing. Lastly, we have this homework. Okay, this is based on this same concept. I want you to complete this and send it to me well before the given time. Most of these questions I have already solved. Okay, you can just go through that. Okay, this one. So I hope so. This will be enough. This is the complete chapter of probability. Okay, so this is for the next whole week. For the nursing and for radiology, this is also for the next whole week. Further, if you have any questions, so you can just note it down, send it to send me an email or mention it. Okay, so then I'll provide. If suppose you find it difficult, so after the deadline I'll solve it. I'll solve this whole exercise for you. Okay, so that's what I'm going to do, inshallah. But I'll submit it, or rather I'll do that. So I'll take your question, consider your question, and also solve this whole exercise, but after the deadline is passed for the next week. Okay, inshallah. Assalamu alaikum.